Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine Podcast Radio. You're about to listen to an episode of Tech Done Different podcast with Ted Harrington. Do you follow the pack or challenge the status quo? Join Ted as he explores how to succeed by going against conventional wisdom. You'll hear leaders in technology and security tell stories about how they achieve their success by doing things differently. Knowledge is power. Now, more than ever.
Welcome to another episode of Tech Done Different. I'm your host, Ted Harrington, and with me today is my special guest, William Benner. William, welcome to the show.
Great to be here with you, Ted. Thanks for the introduction.
Now, there's so many things that I'm excited to talk with you about today, but one of the things that really piqued my interest when we first were getting introduced was that what you guys do is, of course, facilitate laser shows at the Super Bowl and metal concerts and everything like that. So let's just go right to this. That's the sizzle. Let's start talking about that, and then we can dig into what you've learned from that process and how our audience can think differently as a result. So maybe give us a peek behind the curtain in terms of what is that even like? You know, what does that even mean, running laser shows for the Super Bowl?
Yeah, well, it's fascinating. So I'll give you maybe a little bit of my background. So when I was in high school and also college, I was in a rock band, and all the biggest rock bands at the time, talking about Pink Floyd and Blue Oyster Cult and bands like that, all had lasers as a part of their gig. And so we wanted lasers as a part of our thing. We had one of the things I learned was it's not only about how you sound, but also about how you look. It's about the spectacle that you can create. So we created a laser show for our band, and it got a lot of attention for both the band and also the lasers itself got a lot of attention. And other people wanted us to do lasers for their entities, whether it's theme parks or even airports in the mid 80s that we were doing lasers for and that sort of thing. So that's kind of how I got into it. And so the band, what happened with the band happens to lots of bands is like one guy moved up to Jacksonville, another guy moved over here. And so, the band kind of dissolved, but my interest in music and lasers continued. So I met with another guy who also had similar interest in music and lasers, and I said, hey, we should form a company to do this professionally. And so that's what we did. We formed Pangolin Laser Systems in 1986 and just started kind of step by step. And in the our what we did and became kind of more and more prominent as it was featured with more bands and more different things, and these days you see the commercials you see on television, and just lasers are just everywhere. Even the background in the Windows 10, that logo that looks like, it's kind of a bluish thing glowing, that was done not only with a laser, but it was done with a laser that we sold to the guy who did it, and with software that we provided to create that experience. A guy named Adam LeBay out in the Bay Area who did that. So so it's just we've been involved with a lot of these different things, and so got started as it's kind of somewhat accidentally. It's like basically my college project to create a laser show for our band became the business that we now do, and that has led to other things as well. Like, one of the things we discovered within the past, let's say 5 years, was that the laser stuff and the guts, because we make the lasers and we make the laser systems and the software. And one of the things we discovered is that the stuff that goes into those projectors are also can be used for other applications, such as 3D printers and self-driving cars. So that now has become a big part of our business, those kind of ancillary things. So we have our laser scanners that we make are used in scanning microscopes and university studies and a lot of different areas. So it's been a kind of a wild ride, but yeah, we get involved with the Super Bowl and Britney Spears and Katy Perry and any kind of musical performer you can imagine. The halftime at the Super Bowl, the show at Disney's Epcot Center, and just so many others. Yeah,
so let me, first of all, it's not, if a little boy probably has like 10 careers he would want to do in his life, and playing with lasers professionally is probably one of them. So I respect and admire that that's where you are now. So let me ask you about, I was watching a video that you have that talks about purpose. And it really resonated with me because this video that you have, you talked about what really drives you as a leader. And I wanted to talk about it today, some of the ideas that you talk about in that video, because I think they're the kinds of things that they certainly resonate with me, but I think they'll resonate with our audience, people who are professionals in technology and security,
Sure.
people who are leaders, who are very purpose driven. And you talk about one of the things that you mentioned, and I'm curious to hear you talk about how you sort of got to this idea. But you talk about that one of the things that drives you is to do things that have never been done before. And so can you maybe elaborate on that? What do you mean by that? And how did that come to be? How is that part of your belief system?
Yeah, well, it's just, and I'm not sure what it is about me, and it's just such a part of me that it is mysterious to me why why it wouldn't be part of everyone. Maybe it is, but it's just, I don't want to do what everybody else does. And so, like, for example, when we got into this laser scanner business, what most other companies in the laser scanner business do is they copy laser scanners that have been made a way that was invented literally 45 years ago. So they just copy a 45-year-old design, and that's it, right? And it's unappealing to me to do. Look, if it already exists, just buy it. Why build it again? Why redo something that has already been done? So it's completely unappealing to me to do stuff that's already been done. With respect specifically to laser scanners, because it's one of the big parts of our business right now, when I decided to get into the laser scanner business, it's like, obviously we don't want to do what's been done before. So what can we do differently? Where can we really improve these things? And one of the biggest limitations to laser scanners is the heat that's generated with laser scanners. So I'll tell you a story. It's kind of a classic. It's become a classic journey of mine. It's something I see a lot of people do. So you have the idea, right? So what we wanted to do is we wanted to make laser scanners that didn't get so hot, right? And to do that, they need lower coil resistance. But laser scanners also have to be very fast, so you have to keep the inductance down. So now it was thought that it was impossible to create something that has lower resistance, but also without dramatically increasing the inductance. So it's just a belief system. And so, but we said, okay, I got an idea. Let's make a better laser scanner. And here's the classic fallacy. People think that the idea is the most important thing, right? It's like nobody else ever thought of creating a better, faster laser scanner. It's dumb to think that nobody else ever thought of that. But we get into this thing, we say, I got this idea. The idea is the most important part. And so now all I've got to do is go out and find somebody to execute this thing, right? So what I did was, on our journey, I hired the best consultants we can, people, PhD university professors that have written multiple books on motors and stuff like that. And we paid tens of thousands of dollars in consulting fees for them to figure out how to do my idea. Because after all, the idea is the most complicated thing, right? Figuring out how to do it's the easy part, right? That's the fallacy that everyone gets caught up in, right? So we hire these guys. We spent like a half a year on it, and like I say, tens of thousands of dollars. And at the end of the tens of thousands of dollars of consulting fees, the most experienced guy comes to, and he says, what you want to do can't be done, and here's why it can't be done, and gives this physics formula that says that basically the bottom line is you can't do what you want to do. And but by that time, I had already written software to do my own analysis and stuff like that. And I just remember going home one day, because I have this software that runs on my home computer. And I went home one day and I said, they got to have missed something. They just have to. And I had two thoughts simultaneously. The first thought was they had to miss something. And the second thought was, who the hell am I to question these PhD professors that are supposed to know this stuff, right? But I asked the question in a different way. I said, okay, if this thing could be done, what would it look like if it would be done? And I started to put stuff in the computer and construct this thing as well. If it could be done, the wire would be here. And if it could be done, the steel would be wrapped around the wire in this way. And I put this thing in the computer, and what was amazing was it started working. I'm like, holy cow, this is actually kind of doing what I wanted. And so from that point forward, it was a refinement procedure. We spent probably another half a year kind of refining that to get it to work really optimally. Applied for a patent for it. And then, we actually we were building prototypes all along the way, but when I got something that really worked the way we wanted it to work and applied for a patent and stuff like that. So then I was kind of really pissed off, because I was thinking, these guys working for my competitors, why have they misled me? It's like, we spent all this money. Why couldn't they come up with this thing? Right. So, and I'll tell you how I figured out the answer to that. But what's so funny was that I then took the patent application, which basically is all the documentation of how it works, and I sent it to the guys, these two separate consultants, and you know what they said to me? They said, "Well, of course, if you do it that way, it will work." Well, of course. So it's like, well, if the answer is, well, of course, why didn't the hell you tell me how to? So here was the reason I found out that why they couldn't do it. And it is because, so we then, several years went by, and I hired an intern from MIT, and a magnetic specialist intern from MIT. And he came down, and the way they're taught in motor design, that's basically what a laser scanner is, a specialized motor. The way they're taught in motor design is the very first thing you do is this, then you do this, then you do this, then you do this. And the way they're taught, it would never occur to them to go down this blind alley that I went down. Right. So it was interesting. So, for me to figure out why it was that these consultants that I paid didn't come up with this thing. Because like I say, the fallacy you come up with is, I'll come up with the idea, I'll hire people, they'll figure it out, and then I will put together the factory to make it and make tons of money. And this is just an example. And since then, I've just seen so many examples like that. It doesn't work like that. It doesn't work the way you would think and hope that it would work. It makes sense that you'd be able to hire somebody. Look, I could hire somebody to do my wallpaper. I could hire somebody to paint my house. Why can't I hire somebody to figure out how to do this highly technical, complex thing? Well, you just can't,
Yeah. There's a couple elements to that story that, well, first of all, that story is really cool, but there's a couple elements to it that hit home for me, for sure. So the first was, you talked about this idea of, you were told it can't be done. And I don't know if I physically reacted. I probably did. But you say that to, so many members of our audience work in security, right? And they probably all heard that. Or like, oh, challenge accepted. You tell someone it can't be done, they will turn around and go do it. And the second part to your story that sort of fits hand in glove with that first observation is then this idea that you reverse engineered where the breakdown was. You said, I figured out how to do this. Why didn't they? And so then you sort of mentally worked through that process. So what should someone who's listening to this show, what should they take away from that in terms of the sort of the thought process for when things don't go as expected, how to deal with it, right? In your case, you said, well, I'm going to find the breakdown. Why did you do that? What should someone do in order to repeat that or to not repeat what you learned?
Yeah. So it's just been, well, for one thing, the concept of failure, right? And so there's the concept of failure. And I think what most people think of the concept of failure isn't the whole thing failed and the company went out of business and you got broke. I'm trying to do this little thing, this little task, and it didn't work. And they consider that to be a failure, right? Well, failures happen, a million times a day, practically. It's like, seems like everything you want to do doesn't work for some dumb reason. And if you stop right then sure, then it's not going to work, right? And so we have a mindset around here of just, you got to push. It's just, and that's the word we use. It's just pushing. It's just constantly pushing, because the failure, it's just all in the mind for the most part. And you've just got to when something doesn't work, you just either try to go around it or push harder in the same direction you're going. It's just, you've got to push, right? So that is a part of it. And so, and I did, having faster, better laser scanners in the world, I knew was really going to help us in our pursuit, even in the laser light show business. And it's wound up being the thing that works, that enables other things, like I say, like 3D printers and self-driving cars. It is the thing. It's like us and one other company are the companies that serve the self-driving car business, and so it's a really important thing. So I knew it was going to be important. And therefore you've just got to push, right? It's so we're just constantly pushing, and the mindset is one of, there's got to be a way. There's just got to be a way that somebody else missed, that they didn't look at it in the same way. And that's where a multifaceted, multi-talented team comes in. It's like different people with different mindsets are going to look at a problem from different angles, right? And so, okay, we're pushing. It's not happening. It's not, somebody else may be, we've got a guy here who used to work in construction, various things of construction, like putting foam pieces on your house and stuff like that. And he's come up with ideas that we never would have come up with, just because he's seeing it from the foam construction build. Well, when I was in foam construction, we did it this way. And let's try try looking at it, from a different direction.
You're talking about an idea that I cover in my book, Hackable, that we talk about this idea of how you need different viewpoints and you need different team members. Both a company needs their own security people, they need outside resources, and then within that outside resources, they need different skill sets. And that's not a new concept for security. I mean, you see that's why companies have boards of advisors, because they need these different viewpoints. And I think you made the point beautifully about how someone from a totally different viewpoint, like the construction guy, is helping make lasers and adding all these really positive contributions.
Right.
But there was this idea of push is really cool, because I think that a lot of the members of our audience, right, are in some way running against a wall. And the walls could be things like, maybe it's their executive team doesn't understand the problem, doesn't understand why to fund things in a certain way. Maybe they're up against budget constraints. Can you help us think about this idea of push in a practical sense? Like if you said, here's the one thing, here's the second thing, here's the third thing you do in order to deal with a problem and push through a problem where you might be, if you stopped at a point of failure, what would those 1, 2, or 3 things be?
Well, it's funny. I'm afraid I can't give you a step-by-step procedure, and because I haven't really codified in my mind. But what I could tell you is that if you're pushing and it's not happening, then it's just finding. There is no step-by-step procedure per se. It's just, I guess the first step would be realizing that it's not working, right? Realizing that what you're doing isn't working, no matter how hard you push it. Like if I'm pushing against a concrete wall, probably not going to move, right? So the first step would be to realize that it's not working, right? And the second step would be to just start trying other things, and in some ways, the wackier, the better. Right. The more some of the problems I've solved have been just from saying, okay, I'm just going to do this thing. I tell you a specific example. In making these laser scanners at one point in time, one of the things you've got to do is wind wire. It's called making coils, right? And I come up with this idea of winding a coil, and it wasn't working. And so I got really pissed off. It was funny because I can't even get myself back in that mindset. So I said, I'm going to try something completely wacky. I'm going to try this other wire over here with the complete understanding that it's not going to work. And it's funny. I can't even get myself in the mindset of why I even tried this wire. Right. But I tried this wire. I started winding it with the expectation that it was going to fail. And not only did it not fail, but it started doing stuff of like, what's going on here? So I had to go back to the drawing board to even understand what was happening. And I realized there's a whole nother way to wind a coil. And it was because I did something that completely made no sense whatsoever. And so sometimes the thing to do, to say this as advice, hey, try something that you don't even think will work, winds up at least revealing a path that you didn't realize existed. When you're talking about talking to a board of advisors or trying to convince people that why to try to motivate people. Those are in some ways harder problems, right? The problems that I solve mostly are of a technical nature, and there's almost always a technical solution, right? And you just rest assured that if you've got a technical problem, there's almost always a technical solution out there, right? But when you got people involved and personalities and stuff like that, where I have to work with those kind of problems where it's getting to an area of intractability. There's a few people who I rely on that are just really good at that. You could at least bring as consultants, if not actually bring onto the team and say, hey, look, I haven't really been communicating this as well as it needs to be communicated. I'm bringing on this person who's a much better speaker than I am to help to communicate the importance of what it is that we need to be doing. So it's just, for people problems, it's a kind of a different tool set, and having additional consultants and additional people that you can rely on and bring onto the team, I think would be a big part of the solution to those kind of problems.
Love it. So you do have a framework. You do have a codified step-by-step.
It's not something it's not something I have actually codified. It's not like every time I have this problem, I open the file cabinet and say, okay, now what did I use as step one? What did I use as step two? I whatever I do, it's kind of in my head. I call it like tying your shoes. Like you and I tie our shoes every day. And if you say, Bill, how do you tie your shoes? I don't know. It's like this thing goes over this thing, and you just do it so automatically. You don't even know how you do it. It's there,
Totally understood, and I hope I didn't put you on the spot by asking it that way. But
it's not a problem. Yeah.
The beauty of the question, and here's why I'm asking it, is that this is a common thing, right, for our guests, right, where we have a guest join who's really accomplished in certain ways, and the audience wants to know, well, how'd you do it? And they're like, well, I don't know, I just do it because I'm just naturally this way. And so by forcing to talk through the solution, you were very quickly be able to say, well, I guess it's this, and then it's this, and that's that. So that was really helpful.
Yeah, I don't mind being put on the spot at all. I'm not kind of a bashful person, or and I don't mind saying I don't know if I don't know.
So let's talk about. I really like what we're talking about right now, the idea of failure and how you push through it, and ultimately get to success through wacky thinking. I thought that was a great way to say it.
Yeah.
So let's talk about technical failure. You're obviously in the not even the literal business in terms of how you generate revenue, but you as a professional are in the business of innovation and pushing boundaries and things like that, as is most of the people that are going to be listening to this. Yeah. At some point, I imagine that you faced some sort of technology failure, and I'm even thinking, I can never not be wearing my security hat. I'm like, there's software that runs this hardware that runs a laser show at the Super Bowl. How could someone make that not work and make the Super Bowl show not cool? Like that's where my mind goes. So how do you guys think about technical failure? Is there an example of a technical failure that was, maybe a difficulty you had to go through, or if not, one that you could share a story of? How do you think about preventing?
Yeah, well, when it comes to laser shows and that sort of thing, and the computer involved in that, most of the stuff these days is done through network. So the laser projectors themselves are up on truss or wherever they're located, and they're connected to a computer via network, and it's an Ethernet cable, right? And so one of the things that we've got to think about from time to time, and even simulate, is what happens when that network drops, when something, and it could be something dumb like, when you create these huge complex shows, right? There's so many different moving parts and so many different people involved in this during the setup. There's lights that go on these truss, there's the lasers, there's everything else, there's all the sound equipment, and each one of the people, and it all comes together pretty quickly, like in a single day. This can go from nothing to ready for the concert, right? And so people are dragging flight cases across, and so if your cable happens to be in a bad area where somebody unknowingly drags a flight case across and winds up cutting the cable, you've got to have backup plans for that, right? And it's just knowing that this is just like in the security industry where you are. It is at least being cognizant of the potential failure points, right? And trying to deal with the failure points ahead of time and trying to simulate these things. So in these big show setups, what we often do is actually simulate, well, not actually get out a pair of scissors and cut the network cable, but disconnect it at various times and places in the system to make sure that the system can recover and that they've got kind of backup plans for that. And it's a similar thing for safety, because lasers could be what we call an ocular hazard, means it could flash past your eyes, and usually doesn't do anything any worse than flash blindness, like oncoming headlights or something like that. But nevertheless, it's not a pleasant thing for concert goers, right? So we want to prevent that kind of thing from happening. And so these things are done with, believe it or not, red mushroom switch, which we call the e-stop, like emergency stop system. And so, yeah, the e-stop system has got to be tested and implemented. And sometimes there'll be government safety inspectors that come just before the show, and they will want you to demonstrate that the e-stop works in the way it's supposed to work. So there's all of that stuff. And for just to kind of answer the core bit of your question, it's just, for me, it's just kind of preparation. It's knowing what can fail and then testing what can fail. When you talk about security, about a year ago, my company got hit with a virus, a really nasty one. And I'm talking to you right now from a Mac, but we have a number of IBM PC type compatible Windows-based computers here, and every single of those PCs got the virus and was shut down, right? And we had backups, but our backup procedure at the time was, yeah, we do backups about once a week. We could afford to lose about a week's worth of work. It wouldn't be all that big of a problem. Well, it turned out to be a bigger pain in the butt than we thought to recover one week's worth of work off a backup. And so since then, what we've done is implemented several different layers of backups that happen every night. And in addition to those layers of backups, what we do is occasionally, just what I'm talking about now, testing failure, we will actually delete a file and then bring it down off the backup to make sure that it actually worked. Because what you don't want to do is have a false sense of security and say, hey, I got this backup system, it's no problem. And then the file goes missing, you got to recall it off the backup, and guess what? The backup wasn't working all this time. You thought it was. So again, it's kind of being prepared. It is knowing what can go wrong, and then testing and make sure that the thing you think you've got handled, you've actually got handled. Testing it and making sure that your solution, when called upon to do so, when called upon to bring on that solution, that it's actually going to work, and that you're not going to be double surprised by the event, and then surprised, but guess what? Your backups that you thought you had, you don't have, So that's kind of the lesson that we learned the hard way about a year ago. And since then, like I say, maybe once a month now, we will do this kind of, okay, test the backup, make sure that we can recover from the backup. So that was our problem and solution and learning process that happened as a result of that thing.
Yeah, I mean, you're certainly preaching to the choir about the value of security testing. That's how I keep the lights on. Yeah. But you so powerfully, I think, distilled down so many core principles of security in that one story, amongst them being, first of all, we got to assume that bad things will happen. We have to then test for those bad things. We have to even test our own assumptions about what will happen or what won't happen. I mean, the way you said that, maybe a week's worth of data recovery is not that big of a deal. It turns out, well, maybe it is kind of a big deal. And that's one of the things that I see many people in technology really struggle with, that they don't know until something bad happens, how bad it might be. And the last thing I ever want to see happen is many companies suffer just so that they can do it better. Like, that's totally backwards, even though a lot of security people, that's exactly how they think and talk. It's like crazy.
Right.
How you've been through it. So you've had a bad thing happen. You learned as a result of that. If you were to maybe go back in time, what could you have done differently? What should someone who hasn't been through a bad event yet and is saying, I think I'm pretty good, what would the advice be to that person?
Well, for one thing, it would be bring on a security consultant, because one of the things that we did as a result of the recovery process was bring on an IT professional that knew things that we didn't know. Because even in the realm of backup, there's the name brand backup things. And what we wound up choosing was not a name brand based on a recommendation of this IT professional. We wouldn't have even known about this non-name brand one, which works out to be a lot better and a lot cheaper, more effective and everything. But we wouldn't have even known that had we not had this IT professional that we not brought in, right? And so bringing in people such as yourself, companies such as yourself that know this stuff, that it's your business to know it, right? It's our business to make laser systems and laser software and laser scanners. It's not necessarily our business to know how to recover from things, but it is your business, right? And so we would want to bring someone like you on to our staff to test our assumptions, to enlighten us, and to help us to implement the solutions. So that's one of the things that we did. That would be kind of like the biggest thing.
Love it. Well, we've had such a great conversation today, talking about how to push through failure, how to succeed. We've talked about, obviously, the sizzle factor of what the end product is that you guys get to do. As we wrap up here, William, what would be is what's next? Like, can you give us, what does the future look like, either for you personally or for the field or for just innovators in general? How should we be looking through the crystal ball right now?
Oh gosh, it's such an amazing time. Ray Kurzweil predicts by 2030 we will have implants in our brains, and we'll be doing brain to internet interface, what's called BCI, brain to computer interface. That'll happen by 2030. So we know that that's coming because Ray Kurzweil has been very accurate with his assumptions, and of course through Neuralink, Elon Musk's company, they're really pushing that envelope right now. So that's going to happen in the far future. And I hope there's great antivirus software and security protocols in place when that does happen. But yeah, over the next few years, obviously computers will get smaller and faster and better, and laser shows will get bigger and better. So that's kind of what we're looking for.
Love it. Well, thank you so much for being on the show. You've been awesome, and it's been really, really fun chatting with you. And I can't wait for live events to happen again that we can go. I'm going to see lasers on a completely different level now. I'm like, I wonder.
Oh, definitely. And know that they're run by network. Right.
Yeah. I'll be like, where's the cable?
Yeah.
You've been awesome, man. Thanks so much for joining the show, and we'll talk to you soon.
Great.
We hope you enjoyed this episode of Tech Done Different podcast with Ted Harrington. If you learned something new and this conversation made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.